Make Algebra 2, second half of 5.6 lecture. Okay, so the lead coefficient there is not 1, sad face, okay? When that happens, what I do is I write out all the factors of that orange number and the blue number, okay? So it's going to be 4 times 1 and 2 times 2, right? And then I also write out all the factors of the blue number. What is that? What are those, Thomas? What are those? Yeah, 9 times 1. 3 times 3. Yep, so you do that, okay? All right, then you actually proceed similarly to before. You draw your 2 pairs of parentheses. 2 pairs of parentheses. You draw an x. You put your x in the front of each one, but you leave a little bit of space here for your for a coefficient, because you're going to have to put a coefficient in front of x this time. Leave a little bit of space there, okay? All right. And the signs work the exact same, though, as they did, when did I last see you? Wednesday or Tuesday? Yep, so Thomas, what are my 2 signs in my pairs of parentheses going to be? They're both going to be addition. Good job. Good job. Yep. Yep, and then, right, I'm going to label these 2 spaces the blue spaces, okay? So what's going to happen here, right, is we need to choose 2 orange numbers to put in my orange spaces, and we need to choose 2 blue numbers to put in my blue spaces, okay? Simple enough, right? It's just kind of, so this actually isn't too hard. It's just a pain. It's not, once you learn it, it's just a pain in the butt to do, okay? So let me think of the best way to explain this to you. So here's what's going to happen, okay? So, right, once we fill in the right numbers here, we're going to have my answer, right? We're going to have the answer once we fill in the right numbers. How do we know it's the right answer? What do we check for? We do what? We FOIL it back out, right? So we're going to do first, okay? Outer, inner, last, okay? So pay attention to this plus 12 in the middle. Pay attention to that plus 12 in the middle, okay? What's going to happen is when we FOIL back out, when we do the outer numbers and multiply them together, and then the inner numbers and multiply them together and add those 2 up, that's got to give us plus 12, right? That's got to give us plus 12 back, okay? So what I want to do here, okay, right, and think this rule still applies too. If the signs are the same, so what I want to do here is I'm going to pick a pair from this side and a pair from that side, such that when I multiply the 2 outer numbers together and multiply the 2 inner numbers together and add them up, I get positive 12, okay? So if it sounds like mumbo jumbo what I'm saying, hopefully me doing it will help, okay? So I got to think about this. I got to start, okay? I want to pick 1 pair from this side and 1 pair from this side. So let me just trial and check. This is why this is called trial and check, okay? So let's pick a pair. Let's start with 4 times 1 and 9 times 1. Okay, multiply the outer numbers together. 4 times 1 is 4. 1 times 9 is 9. 9 plus 4 is 13. 13 is not equal to 12. So that's not going to work, okay? Let's try this other combination. I'm going to go with my 4 times 1 and my 3 times 3. Outer numbers. 4 times 3 is 12. 1 times 3 is 3. 3 plus 12 is 15. Not going to work, right? We need positive 12. We need positive 12, okay? Oh, man. Okay, so let's try this then. 2 outer numbers. Let's try this pair and this pair. Outer numbers. 2 times 1 is 1. 2 times 9 is 18. 18 plus 1 is 19. That's not going to work. Whew. Okay, let's try this one. 2 times 3, the outer numbers, is 6. 2 times 3, the inner numbers, is 6. Okay. 6 plus 6 is 12. So is that pair going to work? Yeah. Yep. So let's circle the ones that worked. Okay. Let's circle the ones that worked. Good, good. Okay, I think the hardest part of this process then is this last step. You want to make sure you put, so obviously I color-coded this. The orange numbers are going to go in the orange spaces. The blue numbers are going to go in the blue spaces. You just got to put them in the right? We got to figure out, do we put the 2 first? Well, here it's kind of arbitrary because 2 and 3 are the same. 2 and 2 are the same, 3 and 3 are the same. But in general, the way you figure out where you need to go is write down, okay, the product of the outer numbers, right, that was plus 6. Here, this isn't a great example, but product of the inner numbers was plus 6. Okay. So I need to make sure my outer numbers get multiplied together to 6. And my inner numbers get multiplied together to 6. Okay. This is not as big of a deal right here because the signs are the same. So we can just put, it's just going to be 2 and 2 and 3 and 3. Okay, that's my final answer. All right. That's the only way you could, since they're all the same number. Okay. So my final answer is actually 2x plus 3 squared, if you noticed that. But I'll accept either of these as the answer. I'll accept either of those. Okay. Let's do another one. I think if we do another one, you'll see what I mean. Okay. Yes.
If there's like out of all the options, if there's one like people should get
yeah. So we'll actually see one. So if you try all the options and none of them work, then what you do. So if none work, what you do is, that's a good question. You flip the right side and try again. You flip just the right side. Flip the blue guys. You flip the right blue numbers and try again. Okay? If it's still not working, do a prime check. You guys remember the prime check? What I do? Right? Square root of b squared minus 4ac. Right? Where a is the number next to x squared, b is the number next to x, and c is my constant. Okay? So
should we just do that before every single time?
A prime check?
Yeah, to make it go by fast.
I'd say only do it if you're stuck. Because you want to make sure you're not spending too much time on literally an impossible problem. Yeah. I don't know why that works here, but in general, like grouping, you try grouping. Is that what you try? Yeah, I don't know if that works. That's not a method I've seen before, so I won't comment. Ooh. Yeah, I don't want to say something that's wrong. Okay, can I move on to B? First thing I do, Sam Rice. What's the first thing I do? Yeah, there any GCFs? No. Then Sam Rice, what do we notice is going on here? There's an 8 here. That's not 1. So we draw a sad face. Okay? What do I do then? What's the first step I do from here? Yeah, write down the factors of the orange and the blue. So 8 is 8 times 1 and 2 times 4. What about 9? What's that? 1 times 9 and 3 times 3, right? Cool. Cool stuff. Now what do I do? What's that? Yeah, but I set up my problem first, right?
Oh, yeah.
Set up your parentheses. Put an X in, leave a little bit of space in front of them, though, for those orange numbers. We're going to put the blue numbers in the back. What are my signs?
Plus minus.
They're going to be, so look at your notes. So the second sign right here is positive, so they're going to be the same. How do we know whether they're going to be both plus or both minus? What do we look at? The first sign, yes. They're going to be both going to be negative. They'll both be negative. Good stuff, okay? All right. So let's think about this. So the signs are the same. So we need the product of my outer numbers and the product of my inner numbers. When we add them together, it needs to give us 18. That needs to give us 18, okay? When we add them together, okay? All right. So let's try this. Let's try it out, okay? So we need 18. 18's the I'll highlight it. 18's the magic number we're going here for. That's like the Powerball number. Anyway. All right. 8 times 9, outer, 72. Inner, 1 times 1 is 1. 72 plus 1 is 73. Not going to work, okay. Let's try this next pair. 8 times 3 is 24. 1 times 2 is 3. 3 plus 24 is 27. That doesn't work, okay? I need 18. 18's my number, okay? So let's go on to the next orange pair. 2 times 9 is 18. 4 times 1 is 4. 18 plus 4 is 22. That's not going to work. Let's try this one. 2 times 3 is 6. 4 times 3 is 12. 12 plus 6, 18. Yep, so that's the two. Those are the two pairs we want. All right. Good. And then we just got to make sure we put all the numbers in the right space, right? We know the oranges are going to need to go in the orange. blues need to go in the blue, okay? So the product, let's link these together. The product of my outer numbers, that was what, 6 we said? There we go. Product of my inner numbers was 12. It's 12, okay? When the signs are the same, when the signs in the parentheses are the same, it's a lot easier to place the numbers correctly, okay? So just what I would say is put your inner numbers, right? So here's like my inner, you can see how this is like my inner orange number. Put that in like the inner orange space, I would say. So 4, all right, put your inner blue number in the inner blue space, okay? It's pretty straightforward when the signs are the same. Okay. And then process of elimination, we just have one space spot to put the other 2 numbers.
Would it be wrong if you had like the other way around? 4x minus.
So in this, because this pair of factors are the same number, in this particular problem it wouldn't be, but in another problem you could very much get the wrong thing back. Yep.
What if like when you wrote it down you put 4 times instead of 2? How, like what's like a different one?
So if I put 4 times 2, what would have happened is my answer would have been this. I would have gotten, that would have given me, it would have given me that, but look at the 2. All I did was, I can always change the 2 pairs of parentheses around, so that would give me the same answer. Yeah. And then for these guys, these are tough, okay? These are tough. So what I want you guys to do is I want you to factor to FOIL check, right? To FOIL check basically all of them. So let's FOIL check this. 8x squared, my outer minus 6x, minus 12x, plus 9. Okay, 8x squared minus 18x plus 9, okay? Also, there's no GCFs left that we need to pull out, okay? So we're finished with this problem, okay? That's our answer, okay? So kind of a lot to remember, but again, these are nice problems. If you just do lots of them over and over again, you'll get the hang of it, okay? You'll get the hang of it. I'll do another one with you guys. This one, okay. This one's going to be a little tougher, and we'll see why. C, okay. Berhanu, what's my first step? Yeah, do I find any GCFs? Okay, yeah, no GCFs. So I do what? I know what? The 6. Oh no, yeah. The 6 is not a 1, so let's draw a sad face. And then what do? Yeah, write down the factors of 6. 1 times 6 and 2 times 3. And then the same factors on this side. Okay. How do I set up my parentheses? Yeah, so 2 parentheses, put a little x. Leave some space though for the orange numbers. Yeah, and it'll be plus minus. Where'd the plus minus come from?
First one, then second one.
Second sign, yeah, good job. The second sign here is negative, so the signs in the parentheses are going to be opposite. Good, okay, so let's look at that. Let's think about this, okay? All right, signs in parentheses, different, difference. If they're different, we want the difference of the factors, or in this case, the difference of the outer numbers and the inner numbers, okay? So we got a 5, we got a positive 5 here. We got a positive 5, we got a 5 here, right? So we want, when we multiply the 2 outer numbers together, and the 2 inner numbers and subtract them. In this case, we subtract them, we need to get 5. Okay? Does that make sense? Okay. Right, so let's try this. Okay? Outer numbers, 1 times 6 is 6. 6 times 1 is 6. 6 minus 6 is 0. Not going to work. All right, so let's go to the next blue pair. 1 times 3 is 3. 6 times 2 is 12. 12 minus 3 is 9. Not going to work. Okay, so let's go to the next orange pair. 2 times 6 is 12. 3 times 1 is 3. 12 minus 3 is 9. Not going to work. Not going to work. Then 2 times 3 is 6. 3 times 2 is 6. 6 minus 6 is 0. Not going to work. We tried every pair, right? What do we do when we try every pair and it doesn't work? We're not going to see, so not yet. We're not going to see if it's prime yet. We do what? We flip the blue numbers, yeah? We flip the blue numbers. Okay. Let's try this now. 1 times 1 is 1. 6 times 6 is 36. 36 minus 1 is 35. That's not going to work. Do you guys see how this is a pain? Like, you have to trial and check. 1 times 2 is 2. 6 times 3 is 18. 18 minus 2 is 16. Oh, gosh. Okay. 2 times 2 is 4. 3 times 3 is 9. 9 minus 4 is 5. Right, 5 was the number we were going for. Yep. So let's circle those two. Those are the two pairs we want. Okay? Those are the two pairs we want.
Is it more common for it to be the bigger numbers?
What do you mean?
The bigger like bottom ones?
There's not really a pattern.
Oh.
Yeah.
Mr. Richard?
Yeah.
I thought to see if it was like the signs like x plus x minus, it would be like the first sign.
It's a second. It's a second. You look at the second sign first, and then Sorry, I'm trying to not use the word. The primal step here is to look at the second sign. If that's a minus, then it's an opposite. If that's a plus, then they have to be the same. To see if they're both plus or both minus, it's just the same as whatever is in the first space. That makes sense? Okay. Yeah, so we got our factors right now. We got to make sure we place them into the spots correctly, okay? So here's the best way to do that. So let's look. So what's the product of my outer numbers here? That's 4, right? What's the product of my inner numbers? 9, yep. And I want to have what? I want to have a positive or a minus 5? A plus or a minus 5 left over? A plus 5, okay? So what we need to do, we need to make sure this 9 ends up being a positive 9 and that this 4 ends up being a minus 4, okay? So here's the plus symbol right here. Here's the plus symbol, okay? So what needs to happen here, this is going to be a positive times a positive, okay? So we want, in this case, we want my inner numbers right here, right? Because this 3 is going to have a plus next to it when we put that 3 there. Okay, we're going to put this 3 there, okay? And then we'll put the corresponding orange number I got multiplied with right here. Okay. All right, we need the 3 times 3. We need that to be positive, right? If I put it here, do you guys see how there's a minus sign? It would have gotten a negative 9 instead. So I need that to be a plus 9. And then process of elimination, there's only one more space left for each of the other two, okay? Good. So that's done with that problem. How do you guys... no GCFs left, right? I factored all the way, and then I always FOIL back out on these, okay? 6x squared minus 4x plus 9x minus 6, okay? That gives me 6x squared plus 5x minus 6. There you go. There you have it. That's the same as my original problem. Okay, so my answer actually, it's probably a little misleading that I circled that. Here's my answer right here. Shaded in yellow is my answer. Okay, how do we feel? You feeling okay? Good, yeah, it's just kind of a lot to take in, but you'll take it in. You'll practice, we'll get better. 12:45. Come back at 12:45. 1,500 calorie dinner every night, so getting plenty of nourishment. My dinner? Last night it was pork tenderloin and mushroom risotto. Oh yeah, we'll go with that. We'll go with that. What's that?
Are you good at cooking?
I am pretty decent at cooking.
And that's delicious.
All right, AirPod out, please, Wyatt.
Oh, my bad.
I'm pretty decent. I got some signature dishes.
Oh, yeah, like what? What's your favorite thing to cook?
My bolognese is really good.
Oh, yeah. Bring some in, bring some in.
Bring some in. Hey guys, if you guys do well on the next test, I'll bring in some pasta for everyone.
Hey, bro, I'm gonna ace that.
Pasta luncheon in my class.
You could have like a cooking class.
All right, 12:45. Part D. Part D. Let's do Ruby. Ruby. What do I do first? Yeah. So I check for what? Yeah. Just zoom in. Yeah. There's no GCF, right? I notice what? Oh no.
There's only one of that.
It's not. It's not one, right? That's why you're finding that. Yeah. Oh, sad face. Okay. What do we do then? You said. Okay. What were you saying, Ruby? Write down the factors. Yeah. 7 times 1. 20 is 1 times 20. 2 times 10. 4 times 5. Okay. Set up my problem, right? Set up my problem. Leave some space. Leave some space for the orange numbers. What are the signs? What are the signs? Yeah, you said you already found a pair that works? Okay. 1 and 5, you said?
Right.
Okay, cool. Yeah, good job, yes. So how'd you know that those worked, Ruby? They add up to 31 or they what? They subtract to 31, right?
Yes.
Why are we looking for a difference of 31 here, not a sum 31? What do we look at? Signs. They're different, right? Be different, difference, sum, same, okay? Sum, same. Okay, so those are the factors that are going to work. Okay, so we need to make sure we put everything in the right spot, okay? So let's connect my outer numbers that they multiply to 35. They multiply to 35. Let's connect those inner numbers. They multiply to 4. Do we need the 35 or the 4 to be positive? Or the 4? We need the 4 to be positive. How do we know the 4 needs to be positive and the 35 needs to be negative?
35 minus
Yeah, we need to have that negative left over in the middle, right? The negative left over in the middle. All right.
Is there a faster way to do this? Like especially if you have like really big numbers with a lot of different factors, is there an easier way to know?
I won't say. We don't teach it here. I was told department policy is do trial and check.
Why?
Why don't they just have like a button on your calculator that does this for you?
Yeah.
So you can learn how to think critically. Okay, we gotta keep class going. So okay, so I need to make sure I get what? Which of my orange numbers need? Which of my? I'll say. I think it's easier to do this. Which of my blue numbers then needs to go next to the minus sign?
5.
The 5, yeah, right? The 5 times the 7 needs to be negative, so that 5 needs to go next to my minus sign. Yeah, you'll get faster too at this. Like, you'll also get faster, yeah? And then knowing what needs to get multiplied by 5? 7, so that needs to go in which orange space? Here or here? First one, yeah, good. Okay, it sounds like we're catching on. Good. Then that 1 is right there. 4 is there. Okay, then I check. I always FOIL back out. First, outer. Yeah, you guys get faster at this as time goes on. You get better at it. Good stuff. Sounds like we're starting to get into sailing a little smoother. Sailing's getting a little smoother. We got 8 left. All right. Okay. have oh Jade. There you go. Let's have you help walk me through E. What do I do? What do I do first? Yeah, is there a GCF here? No, yeah. What is it? Got it. What's that? Yes. Yeah, so pull 3 out. Right. Notice when you pull it a GCF, it makes your life a lot easier. It makes the numbers a lot smaller. So another motivation. Okay. The right. I noticed what, Jade?
That's first.
Yeah, I got 2 there. No fun. Okay. So what do I write out, Jade?
You write out the factors of each.
Yeah. They're both primes. There's just one pair of factors. Let me make that blue. Yeah. Then I set up my problem. I want to make a point here. Okay. X. Orange space. Little space for the orange number. Blue number is going to go here in the back. What are my signs, Jade? How do I know?
Plus and minus.
Plus and minus, yeah. Good. And then I'm actually missing one thing here. I forgot to pull that. Make sure you pull your 3 down, okay? So you guys forget the 3, you're going to get points off. Okay, you're going to get credit off. Forget the 3 on a test or quiz. Okay. And then, so Jade, the signs are different or the same? So we want what? We want my outer products and my inner products. We want the difference or the sum of that to be 9. Difference, yeah, good job. I got plus 9 in the middle there, okay? So let's see. 2 times 1 is 2. 5 times 1 is 5. 5 minus 2 is 3. That's not going to work. What do I do if nothing works the first time? Switch to the right, yeah. So make it 1 times 5. Yeah, let's see now. 2 times 5 is 10. 1 times 1 is 1. 10 minus 1 is 9. There we go. These will work. Okay. So connect your outer numbers. Their product is 10. Connect your inner numbers. Their product is 1. Do I want the 10 to be my positive or my negative? I want Jade to answer. Do I want the 10 to be my positive or my negative? And how do I know? Positive, yeah. How'd you know? Yeah, we want that. We want it to be a positive left over in the middle there. Okay. So let's think about this. Okay. So we need the 5 to be positive. The 5 needs to go with the positive 10. So where do I put the blue 5? Do I put it in the first blue space or the second blue space, and why? I need that 5 times. Yeah, good job. Yeah, why the first one? Yeah, so good job. Yep. So there, and then the orange, right? This orange 2 here, right? Where do I put that? So the orange 2 needs to end up getting multiplied with what? It needs to get multiplied with a 5, right? So if I put it in the front here, it'll never get multiplied. So I gotta put it in that. Does that make sense? Cool. There's my answer. FOIL back out to make sure you got the correct answer. So 2x squared minus x plus 10x minus 5, 2x squared plus 9x minus 5. That matches what we have here. Okay, we have no GCFs left, okay? So this is our answer. Is that hand paid? Yes.
Does it matter 1 and 5 or together?
It matters. Yep, it matters. All 4 of those numbers need to be in the right spot. Yep, all 4 of them need to be in the right spot, okay? Kate Morgan, why don't you actually do the next one for us? All right, so what do we do for F? Yeah, y squared. We pull that guy out. Good stuff. And we know what here?
That is both
Well, we know. Yeah, this is not a 1 here.
Oh,
Yeah, we know that. We know there's not a 1 there, so we got to do what? Kate?
1 times 6 and 2 times 3.
Yeah, good job. So, yeah. 2 times 10, 4 times 5, 1 times 20. Okay. We need to make sure we know how to write out the factors of numbers, guys. If there is a 1, like where the 6 is. Well, those were the problems up here that were like way easier, remember, from Tuesday? You can just like whip them out, yeah. Just burn through them. Okay, and then we set up our problem, right, Kate? How do I do that?
It would be x.
Yeah, so do 2 parentheses, right? Put an x in each one, put some space for the orange numbers. Yeah.
For the 6, did you also do 3 times 2?
Yeah, thank you, Macy, I forgot. Good, good. What are my signs going to be, Kate?
Both negative.
Why are you thinking both negative?
Because it would be negative on 1.
So when we're trying to figure out our signs, we look at what?
The second
The
one.
second sign.
So
What?
it would be plus and
Yeah, plus and minus. Good stuff. Okay. What am I missing here then? What am I missing here?
the y squared.
Y squared. Yeah. Don't forget to drop down your GCF you pulled out. Okay. Good. Good. And then I want what? I want my outer, the product of my outer, the product of my inner. I want their sum and their difference to be 7. So what do we say? So look at the signs here. Are the signs here the same or different?
Different.
Different. So we want what? We want the sum or the difference of the outer and inner products. Difference. Yeah. Look on the board. Different. Difference. Same sum. Same sum. Okay. All right. So if they're different, we want the difference of the numbers. If they're same. The same. We want the sum. So we want the difference to be 7 here. We want the difference to be 7. So let's try this out. Kate, you see any pairs up there? When you do the outer and the inner multiply together and subtract, you get 7.
No.
Someone want to help her out? You do that. Outer numbers multiply together and the inner numbers multiply together and subtract the 2. You get 7. Anyone see? Want to help her out? Yes, Macy.
We're going to do 3 times 2 and 4 times 5.
Yeah, right here. You see that, Kate?
Yeah.
3 times 5. Right. 3 times 5 is 15. 2 times 4 is 8, and 15 minus 8 equals 7, right? Okay, cool. Let's think about this. Do we want the bigger number? So the bigger number there is 15, right?
Yeah.
Do we want the bigger number to be negative or positive, and why?
Negative.
Let's let Kate answer. Negative. Why negative?
Because the 7 is
Yeah,
negative.
yeah. In the middle, we want there to be a negative left over. So we want our 15 to be negative. We want our 8 to be positive. Good stuff. Okay. So let's look. The product, the outer, this 5 here, right? The outer product, right, is negative 15, right? So we want this blue 5. It's got to multiply with 3 to give us a negative, right? So where do we want the 5 here next to the plus or next to the minus? Minus. Yeah, next to the minus. Good job. And then that gives us one other spot for the 4. And then put the orange numbers in, okay? Where should I put the orange 3? Should I put it here or here? To the left or to the right?
Right.
Why are you thinking right?
Because it's with the negative.
So yeah, so we need, right, so I think you're on the right track. The 3 needs to get multiplied with the 5, right? Right? If we put the 3 here in FOIL, we never actually will multiply these. The 2 numbers that are in the same pair of parentheses don't get multiplied together. So we need to make sure we put the 3 here. Make any sense?
Yeah.
Because when we FOIL back out, we'll multiply the outer numbers together, and we need that 5 to get multiplied with the 3. You guys see that? Are people seeing that? Alright, and then there's only one spot left for the orange too. Okay. Right, and then how do I check Kate's?
The 4.
Oil, yeah. Thanks. Do we have the right answer? Yes, we do. Good job, Kate. All right, let's do Ian Clark. Help me with G here.
I'm a GCF.
Any GCFs?
No.
No, I don't don't see any GCFs, so what do? I know what?
It's
Not a 1 there, right? It's not a 1, so I have to do what? Yeah.
10 times 1.
Yeah, that's fine. If you can't think of what it's called, that's fine. So I'm writing out the factors of both those numbers. Yep. So I did that. How do I set up my problem?
You 2 times 11.
So my parentheses. Right, leave some space for the orange numbers. Put the blue numbers in the back. All right. What are my signs going to be?
Subtraction.
Both subtraction. You're thinking? Why are you thinking that?
Because it's negative.
So we look at the second sign, right? If this second sign is a subtraction symbol, my signs in my parentheses are what? Are they the same or are they opposite? Opposite, yes. Let's just keep an eye on our notes. Good stuff. Okay. So because the signs are different, so when we do the product of the outer numbers and the product of the inner numbers, we want to take their difference and their sum to be 7.
They're different.
Difference, yeah, good job. Good job. Solid. Yeah. Good stuff. Okay. Ian Clark, you see any combinations that work up there? No. So what do we do if nothing works the first time around? Flip the right side. Yeah, just the right side. Just the right side. That's that'll be 1 times 33 and 3 times 11. Let's fix that. Okay. Good. Now, do you see any combinations that work?
2 and 5 and 3 and 11.
Good job. Yeah, good job. Good stuff. So let's write this down. Right, product of the outer numbers was 22. Product of the inner numbers is 15. All right. So so that green number and that red number, the bigger one is 22, right? Do I want the bigger one to be negative or positive, and why? Negative. Why are you thinking negative?
Because so you can subtract it.
So we want it to be negative because, anyone know why? Why do we want the 20? Yeah. We want to have a minus 7 left over when we add them together, okay? All right, I should say when we combine them. We're looking for their difference. Right? When we combine them, we want a minus 7 to be left over. So this needs to be a minus 22. This needs to be a plus 15. So with that in mind, then, how do I know where to put all my numbers?
2 and then 2 and 5 and then 3 and 11.
So 2 goes here, and then it gets multiplied with 11. I think you're on track. 3 and then 5. Good job. Yep. How do we check, Ian? Distribute. Oh yeah, well yeah.
How do you know that 22 is negative?
So let's scroll this back out, okay? So first, we multiply the first, so it's 10x squared. Multiply the outer, that's minus 22x, right? Inner, plus 15x, right? And then last is minus 33. Okay, so our outer, right, that 22 is going to be minus, that inner, that 15 is going to be positive, right? We need these two, we're going to end up combining those like terms, right? When we combine them, what do we need to get back? We need to get the original problem back, right? So when we combine 22 and 15, we need to get what back for our x term? Negative 7, right?
Oh, so then it would always
if
be
the
a-
22 was a plus, then we get plus 7 back.
So the middle number is negative and the higher number is negative.
Yeah, exactly. Or vice versa, right? If the middle number is positive, the bigger number needs to be positive. Yeah. Good job. Yep. So we got that right. Good job, Ian. All right. Good stuff. There. Okay. Good. Okay. I think I got to move on. So we'll skip H and I for now, so we can move on to substitution, the next method I want to teach you. But maybe do those on your own at the end of class. Okay. All right. So let's do J. J here. All right. This didn't see this in Algebra 1. What's new here? What's new? Yeah, what's that? Well, we did that. We did the ones without the number in front last class. Right, those are easier. But what's different here that you've never seen before? It has a exponent of 4. Different exponents we've never seen before. Yeah, different exponents we've never seen before. Man, we've never learned how to factor that. Oh, what might we do? Anyone get any ideas? Okay, so here's what's gonna happen here. So this is a trinomial, right? This is a trinomial, and it's got 3 terms, right? When you see that the middle exponent is just half of that left exponent, okay, you can factor it just like any other, just like a quadratic trinomial, just like the ones we've been doing. The way you do that is you look at this variable in the middle here, the one with the lower exponent, okay? You write u equals that variable with the exponent, okay? So u equals x squared. U equals x squared. You write u equals that variable in the middle, okay? Then u squared equals what then? If u is x squared, then u squared is x to the 4th. And what I do, this is why it's called substitution, as I plug these in down here, right? X to the 4th is the same as u squared, and then x squared is the same as u, right? It's minus 6. It's minus 6. Right? Now, do you guys know how to do that problem? Yeah. So mathematicians love solving problems. And physicists do it too. They take problems and they change them. They do clever tricks to change them into problems they do know how to do, okay, that they've done before. Physicists are like serial offenders on that. Not offenders, but they love doing that. Anyway, so then I factor this. I factor the problem with the u's. So, Chris Clue, you factor that one for me. What about you? Alright, someone help him out. He's going to catch up. Alright, Monica, you factor that for me. Okay, so we did those the other day. Those factoring problems are a lot easier. Okay, and then what do I do then? What's my final step, do you think? We don't want to distribute. Well, you can check to make sure. You can fold to make sure you did it right. But we plug that u back in. Okay, so it's going to be x squared minus 6 and x squared plus 1. That's our final answer. Okay. So it's just like all the other factoring problems we did, right? Except we just had to make that u substitution at the beginning and the end, right? Right. So we didn't know. So when you see stuff like this where the middle exponent is half of the first exponent, just circle the middle variable with its exponent and then set u equal to that. Sub it in. Just plug it in, okay? Okay. Okay. Yes.
What if they're not equal? It's like,
What if what are not equal?
because you said it's one equal, like this square.
Like 6 here and a 2 here. Then you'll learn how to factor those in pre-count. Yeah. Learn how to factor those in pre-count. K, you do the same thing. So Jade. Okay, so we notice, look at our exponents. Right? The one in the middle is half of the one on the left, right? So we don't know how to do x to the 6th, oh no, right? But we can change this problem, right? So what should I set my u equal to? Yeah, u equals x cubed. What's u squared equal to then? Good job, yeah. And then I can plug those in. What do I have then, Jade, when I plug those in? The equation for plugging those u's. U squared, right? And plus what? cubed. I want to, yeah, 6 cubed. All right. So, and then this one, right? I checked for a GCF. Are there any GCFs I can pull out? No, so I'm just kind of stuck with this 9 here. This 9 which is not equal to 1. Sad face, sad face. Okay, for the sake of time, I'm going to try to blitz through the rest of the problem. So we got to write down the factors, the orange factors. So 1 times 9 and 3 times 3. Write down the blue factors. 1 times 8, 2 times 4. Okay, okay. Keep the U, yeah. So now when we set up the problem, we're just going to keep the U's there. Keep U there. U. Space for the orange. The blue in the back. All right. Then one's going to get a plus, the other one's going to get a minus. Okay. Okay. So then they're different signs, right, Jade? So we want, when we do the inner product and the outer product, we want their difference and their sum to be 6. Difference, good job, yeah. So let's see if any of these work. Okay, the second pair works. Okay, so that'll be, I actually have to do this myself, 12. That'll be 6. We want the 12 to be positive, the 6 to be negative, right? So we have to have a plus 6 left over. So we put the 4. Next to the plus, the 2 will go in the other spot, and then that 4 has to get multiplied with 3. Okay. Good. What's my last step then? Once I have the factor here, plug it back in. Or change it back. So it'll be 3x squared plus 4 times 3x squared minus 2. Good. And then I should be able to FOIL back out. All right, it'll be x cubed. I'm sorry. U is equal to x cubed. So when I plug U back in, I got to make sure I put x cubed instead of x squared. Sorry.
If you keep it as U.
Yeah. You just got to remember to plug it to resum to back in. Okay. If we FOIL this back out, then we'll get the original problem back. So it'll be 9x to the 6th minus 6x cubed plus 12x cubed minus 8. 9x to the 6th plus 6x cubed minus 8. We're not done yet, guys. There's one more example I got to show you. Okay? So you can do the homework over the weekend, okay? L right here. This one's not too bad either. L, right? We don't know how to do this, do we? We don't know how to do this. You know, what do you want? What's your idea, Macy? Yeah. Make 2 of them. What do you mean by that? Okay, yeah. So you're on a good start. So what we want to do here, we want to do U substitutioning. We want to substitute in a variable. We want to set U equal to a plus 4. Now what this problem becomes is U squared plus 7U plus 12. You guys see that? I put a U everywhere there's an a plus 4. Yeah.
Do you need U substitution?
I highly recommend it. You can do it in your head, fine, but I recommend it. Okay, and then I factor that out. That's an easy factor. U, plus, that'll be 3 and 4. And then what's my last step? I substitute back in, right? So wherever there's a U, I put an a plus 4. So a plus 4 plus 3 times a plus 4 plus 4, or a plus 7 times a plus 8. How do I check my work? FOIL back out. One thing I want to say right here. When you FOIL back out, this is the one example. This is the only time you won't get your original problem back, but you'll still have the right answer. Why is that? Why doesn't this look like my original problem?
Because your original problem isn't solved.
Yeah, the original problem is not. If I actually expanded the original problem all the way back out, I would get that, okay? Hey guys, good work today. Quiz tomorrow. The homework for this class is due Monday, so you can have time to study for the quiz tomorrow. The quiz review is due tomorrow for you guys, okay? Good work today. I think we did a really good job.